Describe the concepts of potential energy and momentum.
So potential energy, I would start with this one, is a really important topic in physics. And it's not only potential energy when it comes to gravity, which is what I would say the most famous one, and also the first one that I've learned in school pretty early, but also, for example, with any kind of potential. And basically, if you have a potential, then you have what the name suggests, potential for something. In this case, it's for a change of something, which is really abstract.
To get even to communicate where my head's at, I believe a lot of issues in our own personal lives can be solved or worked on using concepts in physics. So when you say potential, I'm not only imagining the potential scientifically, but also the potential of human beings.
Okay. That was just for physics for the moment.
But I think they're very related and applicable.
Yeah, I think so too. But in the case of physics, for example, the potential that I've dealt a lot with was electrical potential. That you have, when you have a charge, then you have a potential, electrical potential, and then from that potential you can derive the force that another charge would be experiencing if it's near that field. So you have a field that builds a potential, or you have a thing that builds a field, and this field has potential. For example, a charge in like an atomic nucleus that has a positive charge and builds a field, but also the Earth itself, the whole Earth builds a gravitational potential. That's why we are sitting down right now and not floating around. And then from the potential, you can derive the force. So in the case of gravitation, it's always attractive. So it just attracts stuff, but it doesn't push things apart. But in the case of electrical potential, you can also push things apart. So you go from a thing that's create a field and therefore a potential, and then a potential leads to a force. Maybe if you use it as your what do you say, as an analogon to other things, then you could say, okay, maybe if I'm interested in something, then I have the potential to be good at it, and then this potential can lead to a force that I'm trying to learn more about it. Maybe if you go from the way of physics to everyday stuff.
Yeah, or like a human being, say, has potential with its the way a human being as an animal is built, with its cognitive abilities, whatever. Then you practice certain things that you're interested in. Does that create the field where then after a while, after you're practicing, it creates this force? And is that then momentum?
Yeah, until now, I haven't said anything about momentum.
Okay.
But you're kind of correct, because momentum is when you.
I'll take kinda. That's good.
Yeah, momentum is when you combine a mass with a velocity. So if a mass and it's moving at a certain velocity, then you have a momentum. Which is, by the way, which is kind of funny, because you also have in German the moment. For example, the Trägheitsmoment, which is the moment of inertia. Okay. But a moment, so a moment in German is not the same than momentum in English, which is kind of confusing sometimes, because a moment in German is a torque in English.
Interesting.
Yeah, that's
it's like an action.
A torque is if you combine a force with a rotation.
Okay.
So if you have, let me see if I have something here. If you have, if you imagine an axis through the middle, and then I apply force here, by pushing it down, then on the main part in the axis, there's a torque that makes the thing moving. And if I don't make it rotation, then just leave it here and push it, then it's just a force because there's no rotation.
Okay.
But if I rotate it, then it's a torque. And if I push it, then it's accelerating. And you have to think: is it in a continuous motion or is it accelerating? So if it's accelerating or decelerating, which is basically just negative acceleration, then a force has to be applied. And then the momentum is also not constant because the velocity is not constant. I hope I'm not making this too complicated right now. Basically, it's just I start with Newton. The first axiom from Newton was if objects that are still or move at a constant velocity remain this way if no force is applied to them. So you're sitting down right now and you will continue sitting down until a force is acting on you.
So what does one do if you're going in a constant and then there's an obstacle or an object, say an obstacle, right? Then what happens and what can happen to overcome it?
So if something is moving at the constant speed or velocity, the difference is if speed, I'm not sure if I'm getting this right because you don't have the difference in German, but in English you have the difference. One of the things, so speed and velocity is with direction, and the other one is just the numbers, so how fast without a direction. But it's not that important. So if you have an object that moves with constant velocity, then it has a constant momentum. And if there's an obstacle, which is at rest, for example, then on impact, there would be an exchange of energy and an exchange of the momentum.
Okay.
So if anything is in between the object that's moving, then there's a force applied to this object. And then you have to calculate how the things will move afterwards, if they are even moving afterwards. But that can get really complicated in the real world. In the textbook example, it stays mostly pretty simple because you assume that no energy is converted into I don't know if there's a correct English term, into inner energy, you would say in German, which means kind of heat or deformation. In a car crash, if two cars are crashing, then a lot of times they don't move further because the energy is converted into the deformation of the cars, and they will also heat up slightly because they are deformed. So you don't necessarily have a movement afterwards. That depends on quite a lot of things. And also, if for the obstacle, for example, if you go back to the real world comparison, if you have enough energy and there's an obstacle, then you just go through it, and you're just obliterating it, because it depends on a lot of things, and it's even more interesting and complicated in quantum mechanics. But yes, that's basically, you could say, if you're on a path and want to do something and there's an obstacle, but you have enough energy and momentum, then you just go right through it. You don't even need to go over it or under it.
The most important thing is that energy and that momentum prior to the obstacle.
Yes, that and also the nature of the obstacle, of course. If it's just a sheet of or a hill of foam, for example, then it's not that much of an obstacle. But if it's a metal wall, then it's quite an obstacle. So it depends on the structure of the object that's moving, and also the structure of the obstacle, and also the movements of both of them. So if the obstacle is stationary or also moving, and also of the thing that is moving, how it's moving, how fast which with what direction, and decelerating, accelerating.
See, what I'm curious about, that's like a physical material world. What I'm thinking about is like in the mind. If like you're trying to work on a goal, a project, to be successful at it, and you do all the things prior to it, and you build energy and momentum, then you realize there's an obstacle to your goal in your head. So then if you have enough energy, you'd be able to get through it. But it's a matter of calculating and measuring that obstacle and what would need to happen to keep that energy going forward, right?
I would say in this kind of obstacle, it's much more complicated, because you in the physics sense, that if you have an obstacle for a thing that's moving, then I would say you basically have a few options, like going right through it, going around it on the left, right, bottom, or top, or find some more elegant way, kind of thinking out of the box. But it's basically just go through it or go around it. That are the main intuitive ideas. But if you're working on something and then you have an obstacle, then there's most of the times there's not kind of an obvious way how to go through it, because you have to figure things out. It's more complicated. So I would say that if you have more energy, then you're more willing to find ways to go through that obstacle, to find the ways how you can avoid it, or how to you can make it smaller or whatever. But you can't just go through it most of the times, I would say.
Yeah, I think that's, in my head, pretty obvious too. Like you can't just go through it usually, right?
Unfortunately, yes.